Why, hello there. Is it hot in here? Or is that just the sensation of foods being burned to release their energy content into the environment? Well, if you said yes to either of them, you would be correct. Because today, we're getting hot for marshmallows. So you may be asking, why would we want to set a marshmallow on fire? That's a waste of a delicious snack. Well, the answer is that our objective today in this experiment is to determine the energy content within a marshmallow by burning it and seeing how it affects the temperature of water inside of a container. And thus we can judge the relative amount of energy that a marshmallow has based off of its chemical bonding and physical properties. The concepts we will be discussing today are thermodynamics and the relative strength of different chemical bonds, although we will only be examining one particular type today. In the end, we expect to see a black marshmallow having been consumed by the combustion, an increased temperature in the water, and ideally we should be able to calculate how much energy is released when 1 kilogram of a marshmallow is burned. Without further ado, let's go ahead and go through the lab. You will see all the materials necessary shown as we demonstrate all the procedures. First, retrieve and put on your safety goggles. After all, safety comes first. Next, you'll need to create a food holding device. Here, we jerry-rigged one using a paper clip and some aluminum foil, just that way we could elevate the marshmallow while it was burning, and stabilize it. Make sure now to measure the mass of the food holder with a marshmallow on it using a properly calibrated electronic scale. Next, go ahead and take an empty can and weigh it using the scale, then fill it with 50 milliliters of water and weigh it once more. This will help you determine how much water you exactly have inside the can in terms of grams. Next, you need to set up the apparatus for the experiment. Using a ring stand, a ring, and a stern rod, or in this case a pencil, you can go ahead and suspend the can about 1 inch to 2.5 centimeters above the top of your food sample, which should be underneath the ring at this point. Now you can insert your temperature probe. As you're seeing in the video, it's important to make sure that you use the clamp correctly, so that way that the wires are not near the open flame, and that the temperature probe is not touching the bottom of the can inside, but rather is only inside of the water. Next, you need to set up your data collection. Make sure that your temperature probe is plugged into the correct logger light box and the box is plugged into your computer, and open the proper program, as you can see here, called 16 Energy of Foods from Chemistry with Veneer Pro. This will help you get your results from the calorimeter as opposed to needing a physical thermometer. Your screen should look like this at this point. You're finally ready to begin the experiment. Hit collect on logger light, and once you can tell it's beginning to collect data, go ahead and ignite the marshmallow and let the reaction proceed. Once the reaction has been completed, go ahead and weigh the mass of your food holder plus burnt marshmallow. This will help you determine how much of the marshmallow was lost due to combustion. You now have all the information required to fill out the data and calculations portion of your sheet, like the one shown here. The initial temperature and final temperature can be ascertained using the logger light program, and all of the rest of the values are simple subtraction problems requiring your other data points. Using the equation shown, as well as the data points we collected, we can calculate how much energy was released in the reaction total, and then divide that by the amount of marshmallow burned to figure out how many kilojoules of energy are released per gram of marshmallow. In our experiment, as we show again on our data sheet, we found that the reaction released 2.737 kilojoules of energy and therefore was about 3.337 kilojoules per gram of marshmallow we burned, since we only burned about 0.82 grams. In this experiment, we only burned marshmallow, so we can't really compare the amount of energy released by burning a marshmallow to the amount of energy released by burning other foods. But we can, in generally, just show the relationship between how burning a marshmallow and the energy that it would contain and is used in your own body is able to be released through combustion and heat up water. And it is a very specific amount based off of the chemical composition of marshmallow, which is mostly simple sugars. In this particular experiment, one rather large source of error is that not all of the heat is released and directly absorbed by the water. Rather, some of it is stuck on the aluminum can and isn't used to heat the water, or some of it is just embraced by the air and therefore not accounted for in the logger light data. It does not accurately represent the exact amount of heat which is released and could create a fair amount percentage of error. Also, because some of the measurements are taken using hot objects, the exact mass cannot be determined, and therefore the amount of marshmallow actually burned can vary depending on how exact the equipment is, based off of the temperature of the food apparatus. These are systemic sources of error as opposed to natural sources or random sources of error, such as the inability to measure or variations in air pressure depending on what else is occurring in the room at the time, which may interfere with the temperature or your ability to get an exact mass. Error could be reduced by having the experiment occur in a bomb calorimeter where there is little room for heat to escape, and also where the exact mass is more accurately measured, so that way all of the heat and all of the mass are exactly tracked. Our data in general is pretty precise due to the amount of significant figures present on both logger light and on the scale. However, we cannot determine whether or not it's accurate because we never received an accepted value for a marshmallow, since not all marshmallows are indeed created equal. Well, that is our presentation today. We hope you go ahead and try out the experiment for yourselves, because not only is burning marshmallows pretty hot, it's also pretty cool.